So here we're going to do a few problems where we expand log expressions using the properties of logs. So here is a list of properties of logs. So we have the first property, which is log of x times y to a certain base b is equal to, look what happens on the right side. Each of the terms inside the parentheses gets a log, but notice what happens to the sign. Multiplication changes to addition. So log of x times y is log x plus log y, and the bases remain the same throughout. Look at the second one, log of x divided by y to a certain base b. Each one gets a log x, log y, but look at the sign here. Division is associated with subtraction of log expressions. Next we have, if we have an exponent n, log of x to the n, and this becomes n log x. Okay, so let's use these log properties to expand these log expressions. So we have log of 100 times y cubed. Remember, this is times. Okay, if there's nothing in between, that's times. Remember that multiplication changes to addition of the logs of each of these terms to the same base. So let's first use the multiplication property. Multiplication changes to addition. So we have log, again, remember the base is the same, to the base 10 of the first number, plus, remember the multiplication changes to addition of logs, and log of y cubed to the base 10. So we've seen this before. We can evaluate this log expression because it's both numbers. So we have log of 100, which is 10 squared to the base 10. If we could write 100 as 10 to the something, then we know we can evaluate the log without a calculator. Plus, remember that last rule which says that the exponent can be written as a factor here now. So 3 times, so it becomes like 3 times log of y. So we are simplifying step by step. Now this log can be evaluated. Remember, log of a number 100. If we could write it as the base, which is 10 to the something, then that number becomes the log of 100, and that's equal to 2. So log of 100 to the base 10 is 2. If we changed the base, then the log of the number would be something completely different. Please watch my previous video evaluating logs without using a calculator. So that'll help you remember this particular calculation we just did. And then that is plus 3 log to the base 10 of y. Now let's look at the next one. Here we have division. So it's log of 25 divided by x, radical x. So that would be log, and make sure you have the base of the number, which is the numerator, divided by, so it becomes minus. So division becomes minus when each one is a log. So that is to the base 5 radical x. Now remember, log of 25 can be evaluated without using a calculator. If we could just write 25 as 5, the base to the something. So let's try. So log to the base 5, 25 can be written as 5. And why do we pick 5? Because that's the base of the log squared. If we could somehow write it as 5 to the something, then that exponent is the log of the number. Minus log of radical x, which is x to the half. Now the next step is, remember, the green highlighted number is the log of 25. Log of the number 25 is the exponent to which the base 5 is raised. So it's just simply 2 minus the half, which is the exponent based on the third rule that we just went over, becomes a multiple here. So that becomes half log of x to the base 5. Now let's do one more. I've added some terms. Maybe I can just add one more. Y cubed z squared. Okay. So when we have a numerator and a denominator, we first start off with log to the base 7 of 49 x squared, which is the numerator, is divided by the denominator. So we go minus log of y cubed z squared. So now each of these can be simplified further, because as long as we have a product inside, we know we can change the product to a sum, right? So our next step is, and remember, I forgot about the base, so let's write down the base as well. So now we have log of 49 to the base 7. Remember the multiplication, if each gets a log, then multiplication changes to addition. Log of x squared to the base 7 minus, and now we're going to split this single log expression into 2. So remember to put your parentheses, log of y cubed to the base 7 plus log of z squared to the base 7. Now we go 49. Can 49 be written as the base 7 to the something? And in this case, yes. If we could write 49 as 7 to the something, and in this case it's 7 squared, that exponent is the log of 49 to the base 7. Plus, this exponent can be written as a multiple, so you can multiply the log with it. 2 log x to the base 7 minus, and I'm distributing the minus. The 3 goes here. We have 3 log of y to the base 7 minus the 2 goes here. 2 log z to the base 7. We're almost done, except that here log of 7 squared to the base 7 is 2. Okay, plus 2 log x to the base 7 minus 3 log y to the base 7 minus 2 log z to the base 7, and we are done.